So, systems of equations, we can really break it down into 3 steps, which I think makes it a little easier. Okay? First thing we got to do is set up our matrices. How many matrices do we have to set up? 2/3-ish, right? There's only 2 we really work with, right? So this first matrix is going to be a what by what? 2 by 2, because we've got equation 1, equation 2, and then we have our coefficients of our x and our coefficients of our y, right? I think the more you label things, the easier it makes stuff. Okay? So what are the coefficients of my x? -5 and 1. If you need to draw that 1 in there so you see it, do it. Okay? How about my coefficients of my y? Good. Good. Make sure these symbols get attached to those lovely, lovely numbers. And then this is technically being multiplied, back it up, by an XY matrix, right? Think about this for a second. Take a peek up here, right? Because if we did matrix multiplication, wouldn't we do -5 times x plus -2 times y to kick us back right to here, right? And this is equal to what? The -16 and the 12. Good. You cool there? Now, you don't technically have to write this part down. It's just me explaining to you why we do things that we do, okay? And what are the dimensions of this guy? This guy's a 2 by 1, and this guy is a 2 by 1. Okay. So the key is I want to know what x and y equal, which means I need to take this guy and move it over to here somehow. How, right? What is that called when you break something off on an equation and you move it to the other side? When you undo something like that. Distribute? No. Like if I had 3x equals 15, what would you do to get the 3 to the other side? You would divide, because 3 and x are being what? Multiplied. Dividing and multiplying undo each other, right? What if it was x minus 1 equals 17? The inverse, right? We're always doing the inverse to move things to the other side. Does that make sense? So that means I have to find what about this guy? I've got to find the inverse, right? That's our goal. So I'm going to label this guy matrix A, and I'm going to label this guy matrix B, so it's a little easier to figure them out. And we're going to make that A look like an A, and not like a curva, because I don't know what a curva is, but that's what it looks like. That was a very odd-looking symbol. All right. So the second thing you need to do is you need to calculate A inverse. And there's 2 things you got to do it, right? Remember talking about inverses? That A, B, C, D thing? It's what you did with me the first day we broke into those groups, right? Remember how we had that matrix that was A, B, C, D? And then what did we have to do to it? Switch what? So what's this guy turn into? Good. -B, awesome. -C, awesome. Phenomenal. And we had to do one other thing. 1 over the determinant. Remember doing that? You remember doing that? So, first of all, what's the determinant of this set? You calculate the determinant before you switch it. What's the determinant of this guy? I need to click into another color. So yeah, -5, -4 gives me +20. 1 and -2 gives me -2. And then what order do I subtract them in? 20 minus a -2 becomes 22, because that turns into a plus sign. We okay there? So this guy is your determinant of A. The more you label things, the more I think you're going to get used to the little notation. Okay? So I need to calculate my A inverse, which is going to be 1 over 22 times, and what's my new version of my matrix? Negative 4, positive 2, negative 1, and negative 5. And I heard somebody already saying it. If you want to jump in and go right into it, you absolutely can. You don't have to show this step. When you multiply by a fraction like this, you're just putting this guy over that fraction. Because isn't negative 4 really negative 4 over 1? Right? When you multiply fractions, you go straight across. Right? So all we have to do here is put negative 4 over 22, negative 1 over 22, 2 over 22, and negative 5 over 22. And you actually don't want to simplify. Your life is going to be easier if you don't bother simplifying this, and we'll see why in a minute.
How did you get the 22 from 20 and negative 2?
Because it was 20 minus a negative 2, so it turned into 20 plus 2.
Okay.
Yep. Great question. So far, so good? So this is my A inverse. So my question to you becomes, do I do B times A inverse or A inverse times B? Why? Because of the dimensions. Right? My B guy, you guys told me, is a 2 by 1, and my A inverse is a 2 by 2. So can I multiply this? No. This is the only way that works. Is that cool? Okay. I'm going to scoot the screen all around so we've got room to do what we want to do here. I might just rewrite it a little neater. Is this supposed to be a 2? No, it's a 1. 22. And then what was the top value for my B? Negative 15 and 12. So what are the dimensions of my answer going to be?
2 by 1.
2 by 1. Very good. Okay. So we're multiplying, right? We're going to do rows by columns, right? I really like this little trick people have been doing. I think it's really, really helpful when you do multiplication of matrices. Negative 4 times negative 16. Negative times a negative is a positive. Easy way to multiply by 4. Double it again. So what's 16 doubled? 32. And 32 doubled is 64. So I got that guy. Plus, what else am I multiplying? The 2 with the 12, which gives me 24 over 22. Okay. How about my next row? 16 over 22 plus 60 over 22. You don't want to add anything to this?
Negative.
Why is this negative? Because there's a negative here. If you watch the recording from 4B, we did not catch that, and we kind of had this nice little discussion of figuring out where our mistake was. It's always a negative. Okay? If you're adding fractions, what do you need? Common denominator. That's why we don't bother simplifying, because this already gives us a common denominator. Does that make sense? Makes your life easier? And then you just have to add the tops together. So what's 64 plus 24? 88. That's going to turn out nicely. And 16 minus 60. Is it going to be positive or negative? Negative. 44. So what's my actual answer here?
44. Wait. More negative.
There we go. Yeah? So, what does this even mean? that's my x and my y, right? Because I'm figuring out what this is. The top number's x, bottom number's y, x, y. So you can even tell, you could tell me x equals 4, y equals -2. I could ask for it like that on a test or a quiz. How else could I ask for it? As a coordinate. Because when you're solving systems of equation, we're talking about two lines crossing and where they meet. That's going to be a point. Does that make sense? Yeah? So our last little step up here is to do the A inverse times B. That's the 3 pieces you want to do. How do you feel about that? Would you like to try one more? Okay. I'm going to turn off the recording here. Okay? But